Okay, so today's session will be about how you can be able to deploy your machine learning models that you've been creating using Flask as a web app platform. So our session today will be done by Bunmi, and she'll be taking us through everything you need to know about how to transform your models and also how you can easily share it with the rest of the team. So in case you've been building models and you want to deploy it to an app, so how do you go about it? That's what we'll be covering today. A brief overview of what we've been doing this past week. So last week, the first week we covered a bit of introduction to Python and data science basics. That's analyzing your data visualization, and a bit more on manipulating your data, same as analyzing, but now more in depth. And then week 2, we covered a bit about now putting all that we learned in week 1 in action by going ahead and doing our own projects. We also covered a bit on data science in the cloud, how you can use the different data science cloud services available. We covered in specific the Azure ML. So I'm pretty sure everyone who was in that session at least now knows how to use Azure AutoML. And then afterwards, for the rest of the week, we covered more on machine learning. So there was the introduction to machine learning, understanding the different machine learning techniques, and of course, regression. So regression is one of the different machine learning methods whereby when you're trying to predict something that's of continuous value, something like you're trying to predict someone's height, or you're trying to predict something continuous, the height, let me see, the weight of something. If you want to calculate the average score, what they'll score in an exam or something, you use regression. So that's one of the methods that we covered last week, and today we'll be doing something similar whereby taking a regression model and you're using it in an application. So I'll hand it over to Bunmi to continue. She'll introduce herself more and then take us through modeling. After her session, I'll be sharing the resources for the remainder of the week. So we'll be covering a bit more on the different machine learning techniques, that's clustering, classification, and so on. So we'll cover that. And then from there, we'll see what the next steps will be. So over to you, Bunmi. You can go ahead and start.
Okay. Thank you so much, Bethany. I suppose everyone can hear me, right? Okay, great. So hi everyone, welcome to this session. I'm so happy to be doing this live with you guys. So today I'm going to be walking you through how to build a web app, for deploying your models. Okay, yeah. A brief intro about me. I'm a data scientist and I currently work at Helen. So Helen is a financial startup, right? And we are in charge of building financial solutions for businesses, small businesses. So yeah, okay. Let me share my screen. Okay, let me share. Okay, can you see my screen?
Yeah, we can see your screen.
Okay, good. So yeah, today I'll be talking about I'll be giving some real life scenarios of deployed models so that you have an idea of what deployment means. So I'll be explaining what it means to deploy a model. And then I'll also be talking about Flask because we'll be using Flask to deploy the model in this session. So there are actually a couple of other deployment platforms, but I will be talking about Flask. Then I also talk about how to save your trained model. So that model you've already trained and done a lot of analysis with. So I'll talk about how to train it, how to save it, and then would build a web interface with Flask, and I will show you how to integrate this model with Flask. And at the end, I would also give a little challenge, which I want you guys to actually try this hands-on by yourself. Okay? So I'm going to be assuming that you're familiar with building a machine learning model. I'm going to be assuming that you know the data analysis process, where you have to clean your data, explore your data, perform a couple of visualizations, and also how to train your data. I'm sure you know how to do dot fit, and I'm assuming you also know how to evaluate your model, right? Okay, so let's start. So a couple of deployed models. So basically what deployment means is that you're literally taking your model from your Jupyter notebook to actually to a usable environment where it's actually applied in real life. So it doesn't just stop at building this awesome model from data gathering, gather your data from probably suites of probably a particular topic, and then you build a model that can predict if this particular suite is sensitive or it's not sensitive, and that kind of stuff. So it doesn't just end in your notebook. You need to actually put this out real life and then use this on real life data. So how do you do this, right? No one would come to your Jupyter notebook and then start writing that code for them to be able to use it. So they need some sort of interface, right? So your codes are like the back end. They need a front end where they can see just a simple UI that shows them, okay, just click this button, then this does this, right? You don't necessarily have to know the complexities of model building and all that kind of stuff. So that's the essence of deployment. That's why you need to deploy your model. So a couple of deployed models is Portrait Maker, right? Portrait Maker is this app, right? You upload your picture and then it draws a portrait of you, right? So behind the scene, we know that there are like ML algorithms that does a lot of processes, transform it, does a lot of numerical computations before you can actually have this image that is a portrait of you. But then no one gets to see that, right? All I see as a user is just an app, right? I upload my image and then it gives me a portrait of myself. So I don't see the complexities of all that kind of stuff. So also is Alexa, Siri, Google Assistant. You don't see the machine translation algorithms. You don't see the sentimental analysis algorithms. You don't see all those complex big algorithms, right? What you just see is a button, you press it, you speak to it, it gives you a reply, right? Just a very simple interface, but behind the scenes are actually complex, algorithms working to give you a good result. Also, other use cases are recommender systems where you visit a website and then you search for probably a bag and then it recommends similar bags based on what other people have searched for. So you see probably like on Amazon, right? You see customers also searched for this. So how does the website know that customers also search for this and to be a good fit for me, right? So these are based on recommender systems. You also have chatbots, right? So they're actually complex algorithms working behind the scene, but because they've been deployed, you don't get to see all those codes and all. So yeah, basically, I suppose you have an idea of why and why you should deploy a model and actually how a deployed model works in real life. Okay, so let me talk a bit about the framework we're going to be using. So it's called Flask, right? Flask is an open source microweb framework. So basically, think about building a simple website, just a micro website, right? With Python, and HTML, right? So you can embed your Python codes with Flask. So it's just a micro web framework, not for building something complex or something too fancy, right? So you can just use it to host your model. So it's typically works like a website where you have to specify the URL. For example, if the name of the website is okay, should I call it shoes, right? Predict shoes, if that's the name of the website. So if I want to go to the home page, it will be predict shoes /home, right? If I want to go to the probably predict a shoe, right? I can say predict shoes slash predict. So just like you're specifying URLs for websites, so also the same thing as here. And then the only difference is that you have to, typically like a normal website, you have to specify your get or post requests, which are called methods or verbs. So if you want to send data to the website, you have to use a post method. And if you want to get data from the website, you have to use a get method. So this method are also called verbs because they're like action words, literally. Okay, so yeah, the thing about Flask that makes it different from others is that it uses what they call templates. So the essence of templates is because you want to display dynamic data right on your website. For example, you declared probably the initial variable or value is 2, but then you want that depending on some conditions, I want it to be able to change. So that dynamic structure, right? Templates allow you to do that. So a couple of other web frameworks, right? Aside Flask, you have Streamlit. You also have the options of deploying to an API if you want to, for example, if you want to work on a mobile device, right? You can you can host your model in a particular API and then just send posts and get requests, just to communicate to that website with that API, right? So that API kind of houses everything. But with Flask, you do not need to build an API to communicate with your model. So you can just embed the model directly with Flask, and also you Streamlit, right? But if you already have a website, right? You already have a website, and all you want to do is just to connect this website with your machine learning model, then you can think of building a separate API that would host and house this model. But for this scenario we're going to deal with today, right, there is no website. We're going to build a website. We're going to build an interface for it from scratch, right? So we can do all that and reduce complexities with Flask, right? So yeah, let's dive in, right? So let me stop sharing this screen and open VS Code. So I hope you can all see my screen, right? Sorry. Uh, can you see my screen? Wait, jeez. Um, I okay. I suppose you can, right? So so yeah, I already created a folder and I called it deploy models, right? So yeah. So now what we're going to do first of all is that, yeah, before I go and start explaining these files, right? Let me open this. Right. So I'm opening a Jupyter notebook. So before you deploy your models, right, you first of all have to build that model, first of all. So the data we're going to be working with is a very, very interesting one. I'm sure people are actually excited about UFOs, aliens, scary things, unusual things, kind of stuff. So yeah, the data set we're going to be working with today is about UFO sightings. That is, where do people report in these incidences of UFO sightings? Where do they report or see strange sightings? So yeah, that's the data set we're going to be working with. So what we want to do is I want to predict, based on probably based on the person's probably the timing, and then the person's latitude and longitude, what country would this UFO probably have happened. Let's assume that the person didn't say what country. So what country would we expect that this particular sighting would be? So that's what we want to predict today. So you can find the data set here. There's a cargo link for that. So let me, I don't know if I can drop this in the chat, or I would probably share, I'll share the link with you later. Yeah, okay. So after you've downloaded the data set, right? So before I continue, what I hope you will do at the end of this session is that you'll be able to save a model file as a pickle, and then you will also be able to integrate the model with Flask. So basically, the columns we're going to be dealing with from this data set is the city, the state, the country, the shape, the shape of the UFO, the latitude, and then the longitude, that is the location, the geographical location. Okay, so first of all, you have to read your data. So the data set here is about 80,000 rows, or I think, but I reduced mine to about let me load it. Let me check the shape. Okay. Yeah. So just a sec. Let me check the shape, right? So UFO is dot shape. So I used mine to about 10,000 rows for speed, and because the data set is quite heavy, so I want it to be so fast. So that's why I reduced mine. So you can just take the time and then deal with everything, but just for speed, right? I had to reduce it. Okay, so now I want to, you can see that the data set has a couple of variables: date, time. It has the city, the state, the country, the shape, the duration. That is how long this person actually had that sighting. Then you have it in seconds, you have it in hours, minutes. Then you have the comments. So you have long comments where the person kind of give like a detailed explanation. Oh, I saw a figure coming out of a light, walking towards the car, that kind of explanation. Or someone just say, oh, I saw a light. So yeah. Then the date it was posted, the latitude, and the longitude. Right. So yeah. So the data sets we need, because if you notice, the duration in hours or minutes is typically the same as the duration in seconds. And I think working with seconds is better than working with hours or minutes because of the inconsistencies. You can see that here it's saying minutes and here it's saying 1 to 2 hours. Right. So yeah, we're going to pick seconds. We're also going to choose the country. We're concerned about the country. And then we're also concerned about the latitude and the longitude. So we don't really need the comments because whatever you're saying, you saw a UFO. So we're not really interested in working with whatever you're saying, right? So we're discarding that. We're picking just the seconds, the country, the latitude, and the longitude, right? Okay. And then finding the various kind of countries. So you can see that they used the short code. There is US, GB, CA, AU, DE. These are the countries that were used. So for me, dropping the cells or rows that are empty. So let's see the number of rows that are actually empty if they are missing values. So UFO.info is. I want to check the number of columns that have missing values. So column seconds has 7 missing values. Column country has 1,292 missing values. Now, I decide to drop it, right? I decide to drop countries without missing values, with missing values, because what I want to predict is actually the country. So so dropping the ones with missing values would make sense, right? So I'm dropping all countries, with missing value, because what I want to predict is the country. So, and then I'm setting this in place equals to true. So I don't have to say UFOs equals to UFOs dot drop any. Same thing. Then I noticed that my country is not numerical. It's alphabetical, right? So what I want to do is I want to label and encode this. So I can choose to do this manually by assigning probably I assign US to 1, GB to 0, and all the kind of stuff, right? Or I can just decide to call sklen.preprocessing preprocessing and then call the label encoder. So label encoder, what it does is that it arranges it alphabetically and then encodes it that way. So you're knowing that it's probably going to give let's see. So US is 4. Let's check it alphabetically. So 1, 2, 3, 4, 5. Now you know that the 5th element in Python has the index of 4 because Python counts from 0. So you can see that it actually encodes it alphabetically. So you might want to take note of that. So yeah. Now the next thing to do is to separate it, right? So you can choose to, we're going to keep a particular part as for validation, right? We're going to train with a particular part. Now you can choose to identify the selected features you're interested in. You can use this way, or you just drop it. So what I mean is, or you do it this way, where you say UFOs.drop, what's the name? Drop country. This also works, right? I suppose this is what you're familiar with. So this also works. Yeah, I didn't specify the axis. Axis equals to 1. Okay, yeah. So I specified this because I'm dealing with columns. Yeah, so by default, it's axis equals to 0, which means it's removing the rows. So because I did not specify the axis, it should an error. So you might want to take note of that. So I'm splitting it on size 0.2. That is, I'm giving the validation 20% of the data, right? And then the remaining 80% to train. So this is a classification task, right? And then I'm using a logistic regression model. So I call the model, it's a linear model, and then I fit it with the train data. Then I make predictions with my X-test data. Now I'm going to use 2 matrix to check the accuracy. So now I'm going to calculate the accuracy score, and then I'm also going to calculate the classification report. Now the classification report gives you more than just accuracy, right? So I can check the precision, I can check the recall, I can check the F1 score. And these are actually even very, very important metrics you want to look out for. So you don't want to be having poor precision, right, for some classes, right, and then having great accuracy. So you can have an accuracy of, like here we see we have an accuracy of 96.8% accuracy, right? And then you can have a very, very ridiculous precision, of 27.27 or 0.46. So this would show you how well your model generalizes, basically. So yeah. Okay, so let me do this, please. Yeah. So you can see the predicted labels, right? So the reason why some of these other labels are probably 0 it's because of it's imbalance. So there are probably very few instances of somebody from CA or somebody from DE, and that's why it's giving them 0. But you can see someone from GB, from US, from AU, it's giving them high accuracy because it knows these people very well. So the CA and the DE are like outliers. So you might want to take note of that. Now, this is occurring because I just took a very small part of the data set, right? I took the first 10,000 rows. So assuming I use the whole 80,000 rows, probably it's going to be more balanced. So yeah, I might want to take note of that. So you're probably not going to see the same result as me, right? Okay, so now that we're done with building the model, right? I already have the model, and the model, I save it as model, right? So it's saved in this variable, and then it gives me prediction, and I'm okay with the accuracy. So the next thing I move on to is saving this model. Now there's a library in Python called pickle, right? So what pickle does is that it flattens whatever you want to save. It kind of flattens it. So it takes that model, flattens it, and then saves it as a file. So I'm going to call the file UFO model. And please note that when you're saving a pickle file, it has the extension .pkl, right? So that's the extension it has. So UFO model.pkl, that's the file name, right? And then I'm dumping this model into this file name. So I'm writing it into a file called UFO model.pkl. Now, if you want to load the model, all you need to do is just to call pickle.load, then the name of the model. So you open that particular file, and then you can make predictions. Now note that we used 3 features to train the model, and those are okay, let me go back to it. We use the seconds, the latitude, and the longitude, right? So you want to take note of that. So if you want to make a prediction, right? So 50 here is the second, 44 is the latitude, 12 is the longitude. So if I run this, right, it predicts GB as that country, right? It predicts the country code. Okay, so now that we've pickled our model, and then we've built the model, so the next thing is to deploy with Flask. So now you need to create a couple of project files, right? So you have the web app, like, that houses everything. You need to create a folder called static, and inside that folder you're going to have a file called CSS. You also need to create a folder called templates, right? And inside that folder, you're going to have what they call index.html, and then your notebook, and then your model. So looking at my left hand side here, right? So this is my folder, which contains web app. This is my static folder. I created that already. This is my template folder. I created that already. And then I have the requirements folder, my model, right? I have the notebook I'm working with. So this model here is as a result of the pickle function I called, because I actually saved that model as a file. So that's why you can see UFO model.pkl. So now the next thing to do is to create a requirement.txt file. So my requirement.txt file is going to have scikit-learn, it's going to have pandas installed, it's going to have numpy installed, it's going to have Flask installed. So now that I created that file, the next thing is to install these variables. So I do Ctrl-J with Windows, and then I'm going to open a new command prompt. Right. So I already have a working environment, and that is called base. Right. So I already have a working environment, and now I can install all these. So if you don't have a working environment, please create a Python environment, so that you would not have conflicting dependency issues. So you want to create a separate Python environment, you activate it, and then all you need to do is do pip install, just like the way you do pip install, but then the keyword is R, -R, like -R, then requirements.txt. So this is good if you want to install probably a lot of requirements at once, right? So you don't have to like be installing one by one. Then you run it. Okay, I have to move to my current working directory, which is sure, yeah, your models. Great. So now let me try to run it again. So yeah, I already got all this installed. So you get probably gonna see this if you have all this installed. So now that I have my requirements settled, right? The next thing you want to do, if you've not done it, is to create these folders, right? So the next thing I'm going to do is to start with my template folder. So inside my template folder, I'm going to define a file called index.html. So now index.html just contains how the web page is going to look like, right? So just like your typical HTML, you have the IDOC type, HTML head. For those of us familiar with websites, building websites, it's going to be like easy for you, right? So most important, you set the title. So I'm naming it UFO appearance prediction, right? And then some emojis. And then I'm not going to add the so I'm going to create a separate file, right, for styling it. That's going to be in the CSS folder, right? So yeah, don't take note of that. Okay, so yeah, then what else to take note of is this. So this is a paragraph. According to the number of seconds, latitude and longitude, which country is likely to have reported seeing a UFO, right? And then I'm going to create a form action which has the method post. That is, this is going to send my results to a particular through a particular link, which is the URL for prediction, right? And what is going to send is going to send the user's entry, which is either seconds, latitude, and longitude. So it's going to need this, and then I set it as required. That is, yes, these variables are actually needed for prediction. And then it's going to, when you click on predict where the predict country where the UFO is seen, right, is going to return a variable, or it's going to return a value, right, which is the prediction text. This is going to be displayed here. Now, if you notice these two curly brackets, what does it mean? I initially talked about templates, and then I talked about dynamically changing values. So the essence of this double braces is that whatever value, right, you put in here, it's dynamic, it can change. So initially, what if it's GB, right, and then the next prediction is US, right? So that allows for dynamic changing, right? So yeah, now that you're done with the index.html file, you want to go to create your CSS, right? Okay. Yeah. So now CSS, declare a couple of variables, right? So what do you want to do? Okay, I want the box to look like this, the grid, the input, the body, right? The width, the height, the color, how to align the text, spacing, font size, and all. So yeah, you declare whatever editing you want to give, or whatever style you want to make your form to look like. So you do that here in your style.css. And then the third file which you're going to create is called the app.py. Now, app.py is the interface between your Flask website and then your model, right? So it's a Python file, so that is what communicates. So that is the linkage between your model, your PKA file, and then the Flask website, the HTML and CSS. So now all you need to do is import NumPy, because we're going to be using NumPy. We're going to import Flask. We're going to import pickle, right? So first of all, you create a Flask app, and you need to do that by just saying app equals to Flask underscore name. Then you load your pickle file, which is the model, and then you declare the route. So I was talking about the URLs looking like website URLs. So this slash wherever is just going to be the name of the website, then slash, that means it's taking you to the index.html, which we already defined, which is like the home page. And then it's creating another route slash predict, right, which is going to perform a post method, that is, take these values, right, send them to the app.py file. App.py file generates the prediction and then sends this back to your index.html, which is going to render your results for you. So now, when this happens, right, when it calls this particular URL, what it's going to do is it's going to accept the values from your form, right, which is from the index.html, then convert this into float variables, right, and then make predictions. So model.predict your final features, right, and then this is the output. The output is the first prediction, right, and then these are the countries. That is the full meaning of AU is Australia, CA is Canada, I think GB is Germany, UK, US, right? So then we render the results, right, has likely country, then in this format. So this is also important, right? This makes your app to run. So this is what makes your app to run when you call app.py. So if name equals to name, app.run, debug equals to true. So now that you're sure that you've made all necessary changes, so you've created this app.py file, you've created the style.css, you've created the index.html, you're sure that all this is properly saved and in their proper location, right? So if your index.html is not in your template file, you're going to get an error. Yeah, definitely. So now let our server start running. So to run your server, you need to just call python app.py. So yes, the server is running. It's running at this particular link, right? HTTP 127, blah, blah, blah. So this is the link of my own local host. So yeah. So this is how the website looked like. So you can see, according to the number of seconds, you have latitude and longitude, which country is likely to have reported seeing a UFO. So now this is what is presented to anybody, right? So they don't have to go to your notebooks and then start declaring variables. So all I need to do is write the number of seconds. So if I say 30 seconds and then the latitude, okay, let me pick a data from, okay, let me say the latitude is this, right? And then longitude is this, right? And I say predict, okay? This must be, sorry, I think I made an error there. Yeah, I probably made an, let me check. So it's saying, okay, just a sec, let me read here. So listing notices must be integers or slices, not string. So a simple debug the output. So because I set debug equals to true, so it automatically reflects my changes. So I want to know what's up, right? So run this again. Yeah, good. Oh yeah, so this is my hero here. So it's predicting US for me. Okay. Okay. Getting is yeah, okay. So the output I'm getting is not integer, right? Okay, so now let me try again. One. Yeah. Good. So what now? Yeah. So what happened was that I was trying to make an integer a I was trying to make an integer a in this, would I call it an index? Yeah, basically. So now I'm getting the country code, right? So if I try with another country, let me say I have 20, and I have 26, and I have let me try another longitude if it exists, right? Okay, right. Predict says GB. Oh yeah, you're not going to probably use random variables like me. You're probably going to have like real coordinates, to test that with. So yeah, that's how it works. Okay, so if you have questions, you can ask, I suppose.
Thank you so much, Bonmi. I'm not sure. Oh, we have Oluwafemi. So Oluwafemi, you can go ahead and ask your question. You're muted. Oluwafemi, you're muted.
Sorry, can you hear me now?
Yeah, we can hear you.
Okay. Okay, well done to the tutor. It was explanatory, it was an eye-opener. I wanted to ask for something. When you were teaching, you said something about creating separate environments for Python and the likes. I don't know if you can buttress on that. Because I look at it, if you said you have to install a separate environment for scikit-learn and those other libraries, what if you have a kind of package like Anaconda, which actually has these libraries embedded? Like, do you have to still recreate another environment for them? That's my question.
Oh, okay. Thank you for your question. So in scenarios where you have like Anaconda, the reason why you're creating a separate environment, although this probably wouldn't cause dependency issue, is actually to avoid dependency issues. So for example, you created an environment and this environment works very well for a particular project, right? So you do not want to destroy that environment while trying to use another project for it. So it might happen that certain versions, probably scikit-learn version 0.9, right, works well for these projects you use this environment for. But then the new dependency you are installing, right, is probably is using scikit-learn 1.9. So you know that it's automatically going to discard the old version and use the new one. So and that might actually cause your old project to fail or not to work again. So in that scenario, it's safer to create a new environment. Now, whether you are using Anaconda or you're using just Python, right, you can always create a new environment and then install these new dependencies in it. Probably if your new environment comes with scikit-learn already installed or Python already installed, good for you. But if you're creating something from just Python, you're probably not going to have pre-installed libraries. So it's always good to install everything.
All right, thank you.
Yeah. Okay. Okay. Any more questions?
Okay, it seems like there's no other question, meaning I think everyone understood what you taught. So that's the assumption you're going with. So thank you so much, Bunmi, for the session. Lukman, do you have a question?
Yes, thanks for the insightful session. Good evening. My questions goes thus that I think for someone to do this kind of work, one has to be very talented or one has to have the basic knowledge of web development. So I think with this type of project, can we hire someone if we are project our model in a project? Can we actually hire someone to do that for us if they don't have the knowledge of maybe machine, or do you get
Uh, I I think I get
what
your
I
question.
what I mean is this kind of work to embed this kind of machine learning model in a project, in a web app or in a mobile app. One will have to web development. I mean HTML, CSS, and JavaScript. You have to know all that before you can actually embed it. Because all the codes that you are writing for us now, that you actually showed us, I don't think only the person that is actually good at web development will understand or have the basic skills. So I mean, for me, I don't understand all the codes that you wrote in HTML and CSS and stuff. So I mean, uh, can can someone just discard this session, or we actually need to learn it? Because I mean, in most companies, we have people that do that, or is it a basic requirement for a data scientist or a machine learning engineer to know this stuff? That's what I'm trying to get at.
Okay.
Do you get the question?
I did, yeah. So yeah, thank you for your question. I think the codes, right? You probably do not need to have HTML, CSS knowledge to know how to do this, right? It's pretty easy. It's not like building a website where you need to write a couple of codes, just something simple to test and allow people to use your codes. Although there are actually other platforms that you do not have to write HTML and CSS codes to deploy your model, right? So you might want to look at Streamlit, right, where you do not have to write HTML and CSS codes. But I think for just testing purposes and to get feedback or having people try out your model, you don't need so much code to get started. And on collaboration, yes, because in companies, big companies, you're probably not going to build your whole website and then design the whole front end and all. So yes, there's somebody to do all that. All you need to do is get your have your app.py file that connects that website with what you're doing. So this is just like introducing you to how it looks like. So you basically know you have to know like a bit of this, a bit of that. So a bit of okay, you know where exactly to insert your Python code. So that's just the reason why you have to like just know a bit. So you're not required to go and learn web development, right? You can just use this to just set up something basic. And then if you do not want to at all have to do with HTML and CSS at all, there are actually other platforms that do not require you to do that. So you can look at Streamlit, or you can decide to deploy an Azure. So you can do that with Azure. So yeah.
Yeah, I think to add on what Bonmi says, when you go for a job interview and you're telling people you know how to train models and so on, sometimes they might require you to like do a sample of what you've done, or as a prerequisite before they might check out your work. And if it's just a recruiter who doesn't know anything about code, they might have no idea of what you've been able to do. But if you're able to demonstrate with a simple app just how your model is working, that's enough. Yeah.
Definitely.
Okay, I'm not sure if we have any other question. Anyone else? Okay, there's someone who's asking about the recording and the documentation. Everything else will be sent on Discord, so the recording to this session, as well as the link to everything you need to get up to speed with what was taught today. So check out Discord in the next 2 or 3 hours and you'll find everything there. Oluwafemi?
Okay, sorry. A little bit follow up on question Lukman asked actually. Then I want to ask, though I was working with something recently, I started the web development part recently, and I noticed that the way it was started, okay, and a folder was created, and then the required maybe folder or either pictures or what will be used was stored in the same folder. So I'm just recommending more or less like a follow-up, though I might still have to go and do research on my own. Now, you said all these required text, if there can be a kind of a demo of how you save it inside the folders, like how you group all these requirements together, just the kind of background work. Okay, the app.py, the this, okay, it's in a singular folder and like so that's just the picture I'm having, though I've not really dived much into it, but I'm just looking at that. So I don't know if there's anything as regards to that.
Oh, okay. I think you're asking about the project structure, how you
Exactly.
put. Oh,
Like
okay.
save the files inside a singular folder and then how it connect to each other.
Okay. For Flask, right? You just need to take note of two major folders, right? Everything else stays in the root folder. So you just need to take note of two. So the first is the static, where you have your CSS. You can call it whatever. Okay. And then the second is the templates. So now templates must be named templates. So that's probably one of the rules. You can actually check more on the documentation. I guess that would really guide you, right? But the two important folders you need to note, the static and the templates. Yeah.
All right, thanks.
Any other question?
I don't think we have any other question. So we can go ahead and end our session today here. If you have any follow-up question, be sure to ask on Discord. Everything that you may need to ask is on Discord. And then probably I should share the link for the curriculum so that you know what to do, what we're doing next. So give me a second. So this is the link to the curriculum at aka.ms 30DL, and then the 30 days of learning, 30DL, the data science DS landing page. Okay, I've confused myself, but that's the link, 30DL DS landing page. So in that link, you'll find everything you need to know about where you're supposed to be today, which is having deployed a model. And then from there, as I mentioned earlier, this week we'll be doing a bit on more machine learning, including classification, clustering, time series, and we'll conclude with natural language processing. So this has been like a really packed number of days. So I'm sure you've been learning a lot. So yeah, I think that's it for myself. Just continue following up with where everyone is. And in the last week, the week of 5th July, we'll be having a capstone project. So ensure you keeping up with everyone so that by the end, as we close the session, you'll be able to do a project all on your own. Otherwise, I think from me, this is goodbye. Have a good rest of your day. And yeah, we will chat later for the next session.
Okay. Bye, everyone.
Bye.